Hi everyone, we're now going to start chapter 12, which is all about describing distributions with numbers. This is a really important chapter because a lot of the ideas and the concepts that you'll be learning about in this chapter will be repeated throughout the rest of the semester. So we'll come back to a lot of these ideas quite a bit. You'll use a lot of these different concepts and other things you'll be learning about. So I like to think of this as being a very pivotal chapter in the textbook. And again, we're starting with the cartoon. So in this chapter, you're going to learn about box plots, which is another way to graph quantitative data. And I thought I would start with a little cartoon all about box plots. So I encourage you to look at that a little bit later on. Okay, so let me just move this a little bit out of the way again. So in the last couple chapters, we focused on how we can use graphs to describe data. And in chapter 11, we focus specifically on quantitative data. Chapter 12 is all about how we can not only use graphs to describe quantitative data, but how we can also use summary statistics. So if we ever ask you to describe a quantitative variable, there are actually three key things that we would like you to focus on. So again, you would want to focus on the shape of your distribution, and we talked a lot about that in chapter 11. We want you to focus on where the center is of the distribution, and we also want you to be able to focus on variability. Now back in chapter 11, we learned about how to sort of eyeball a histogram and talk a little bit about center and variability. In chapter 12, you're going to learn about some more formal measures of center and variability. So how can we actually compute some numbers that tell us about center and variability, and how can we interpret those numbers? And you'll learn that the numbers you compute are going to depend quite heavily on what the shape of the distribution is. So we always encourage you to start by graphing your data, looking at the distribution, and then deciding from there which type of measures would be most appropriate. So I want to know what you think. I want to know what you know so far coming into this chapter, or perhaps you've already read through the chapter and now you're watching the video. So let's say we have 9 students and we've measured their weight in pounds, and I have displayed those 9 weights here on the screen. So what I would like you to do is pause the video and try to answer these questions before you see the actual answer. So I want you to think about, what do you think the mean is, or the average of the 9 different weights? What is the median, and what is the mode? So how are these 3 things different? Maybe you'll come up with the same number for all of them, maybe you won't. Take a moment here to try to figure this out. Okay, so before I would figure this out, I would actually put everything in order from smallest to largest. And when you have a very small data set like this and you're going to do things by hand, I would encourage you to do that, especially if you're going to look for something like the median or the mode. It's going to be a lot easier if the numbers are in order from smallest to largest. So if you do that, you should have 100, 100, 100. So I'm just writing out the numbers in numerical order, from smallest to largest again. And as always, I will encourage you to check my numbers here, my calculations. Okay, so we have all 9 of them. They're in order from smallest to largest. So what is the average? So finding the average would involve adding all the numbers together and then dividing by the total number that you have in the data set. So remember, our total number is n equals 9. So when we have n, we're referring to sample size. So if we add all these numbers together and divide by 9, you should end up getting approximately 143.3. So again, the key thing to note about the mean or the average is that you're taking into account the entire data set. All the values in the data set are going into computing the mean or the average. What is the median? The median is simply that number that's in the very center of the data set, the physical middle of the data set. Now we have 9 values here in the data set, an odd number. So the median then would be that number that's in the 5th position, because that gives us 4 numbers in front and 4 numbers after. So the middle of that distribution is 125. That's our median. The mode, which we're not going to really use a whole lot in this course, and I don't even believe Chapter 12 gets into the mode in much detail, but I wanted you to know what it is. The mode is the most frequently occurring value in the data set. And you might have one mode, you might have multiple modes. Here, as you look at the data set, you'll notice that 100 appears 3 times, and all the other values appear only once. So in our case, the mode would be 100. Now, certainly you could have multiple modes in your data set. Again, you might have just one mode. When we look at a histogram, you might remember that we might see a histogram and there's like this peak in the distribution. That's where the mode is. So when we have just one peak, we call the distribution unimodal. And the peak could be just one value that's occurring very frequently. It could be an interval of values that is occurring more frequently than other intervals. Sometimes you might see distributions that have 2 peaks, and we would call that bimodal. So bi would be 2. So if you hear those terms unimodal, bimodal, it has to do with how many peaks there are in the data set, and the peak would be where the mode is. Okay. So that's what we have for center. Now the next few slides I'm going to go through rather quickly because I'm thinking that quite a bit of this might be review for several of you, but of course you can pause things and come back to it if you need to spend more time on it. So again, with center, there are 3 main measures of center. There are 2 that we'll use more often in this course, but we want you to know the difference among all 3. So the mean is just the average of all the data values. Again, sometimes we'll actually call that the average, so we might say mean or average. That means the same thing. The median, again, is the middle value in the data set, so sometimes we'll use an uppercase M to symbolize the median. And then the mode, again, would be the most common number in the data set, or where the peak is, where the largest or biggest peak is in the data set. And these 2 will be ones that we'll use quite often in this course. Again, I wanted this to be here in the slides in case anybody needs this. But to find the mean, you add up all of your data, add up all the numbers in the data set, and then divide by the total number of data points. And so here's just a quick example if you want to look at this a little bit later. We have a data set. This data set has 6 data values. We add them all together, divide by 6, and that will give us what the average is. Finding the median, I think, might be a little bit harder, and it might not be something that you normally do. I think finding the average is maybe a little bit more common than actually finding the median of the data set. And how you find the median is going to depend on how many values you have in the data set, whether you have an odd number to start off with or an even number. So again, the very first super critical step is to order all the data from smallest to largest. You then count the total number of observations, your sample size, to determine do you have an odd number or do you have an even number. If you have an odd number, then the median is the data point that's right in the center. So in the last slide where we had the 9 students, that the median was right in the middle so that we had 4 above and 4 below. Now if you have an even number in your data set, it's a little bit different in terms of getting the median, because if you go to the actual middle, you don't have just one value, but there are 2 numbers that are right in the middle. So you find that middle pair of numbers and you average them, and that'll give you the median of the overall data set. And this is just a little tip that might help you, especially if you have a bigger data set and you're not quite sure what position the median is in the data set. So a key with this formula is that you would only use it to identify the position in the ordered set of data where the median is. So you would take your sample size plus 1 and you would divide by 2. So for example, let's say that n equals 10. So 10 plus 1 divided by 2, that's going to equal 5.5. So what that's telling you is that the median is in the 5.5 position if you've ordered the numbers from smallest to largest. So you would count into the center 1, 2, 3, 4, 5. And between values 5 and 6, that's where your median is. And so since this is an even number, you know that that means you're going to average the values in positions 5 and 6 to get your overall median. So I wanted to practice this a little bit just so you would see what this looks like again with a couple of data sets, one that has an even number, one that has an odd number of data values. So again, what I would like you to do is pause the video for a moment, and I want you to try for data set A and data set B to find the average or the mean and to find the median. So try to do this on your own, and then we'll come back and look at what the answers should be. Okay. So hopefully your numbers are matching what you're going to see here in a moment. So here's data set A. And what I hoped that you would do, the very first thing to do would be to order the numbers from smallest to largest. So if you forgot to do that, then your average should be fine, but your median is probably not correct. So again, oops, I just realized that I didn't find the average here. So let me quickly compute that, and then I'll come right back and show you what that should be. Okay, so the average of these data values should be approximately, so mean, sorry about my writing, 23.1. So hopefully that matches what you got. Again, if it doesn't, let me know. In terms of the median, again, we want to order everything from smallest to largest. And this is an odd number of data values. So once you have it ordered, hopefully you know that you would just go in to the number that would have 3 above and 3 below. That would give us 25. But if you weren't sure about that, again, you could use that formula that I showed you earlier to identify the position of the median. So n was 7 in this case, plus 1 divided by 2 would be 4. The fourth position gives us what the median is. So again, it's extremely important that the data is ordered from smallest to largest for you to be able to accurately find what the median is. In our next data set, again, the mean or the average. So I'm sorry that I'm not showing all the calculations to get this. If you'd like to see that, please let me know. But hopefully everyone knew just to add everything together, divide by the total number of data points. And here we get approximately 6.9. I'm rounding to 1 decimal point. And again, here the middle position. So with this data set, we had already ordered everything from smallest to largest for you, so you didn't have to do that here. We have an even number in this case, so to find the middle position, again, we could take the number of data points, 8 plus 1 divided by 2, that gives us 4.5. We go in 1, 2, 3, 4. 0.5, that would be the average of 6 and 8, and that would give us 7. Okay, so quickly before we wrap this one video up, I wanted to see if you knew what was wrong with this statement. So it's really important to understand the difference between the mean and the median. How are they different? So they're in some data sets, maybe those numbers will be the same, but they refer to 2 different values within the data set. They're obtained in different ways. So this was actually an article that appeared in USA Today. And when the article initially appeared, it had a sentence that was incorrect. So they soon corrected it, but I want you to see if you know what's wrong with this. So the sentence read, in 2005, the mean reading score, half scoring above and half below, was 508. So what is wrong with that? Hopefully you're thinking, well, the mean doesn't tell us the point in the center where half is above and half is below. The mean is the average of everything. So really, when they say half above and half below, they're referring to the median there. So that's something to keep in mind when you're reading articles and they refer to an average or a mean or a median. Knowing what that's telling you about the data set, that can be extremely important, and we'll talk about some examples a little bit later about why it's really important to use the most proper measure of center given the kind of data set you have and given the message that you're trying to convey to your readers. We'll stop here and we'll pick up with more discussion of variability.